Hello guys, welcome to Science Learning Gateway. I hope you all are doing good. So today I came up with a new tutorial for you all. In that I am going to discuss for class 10 students chapter number 2, acids, bases and salts. This chapter already I have covered. You can check that in the playlist of class 10th. And in this tutorial I am going to discuss some of the important terms, some important reactions and some important salts and its uses. Means in short we are going to discuss this chapter. What is important in this chapter that we are going to discuss now. So let's start with our discussion. So before starting guys, I want your support and motivation so that I can make more videos for you all, and for that you have to comment in the comment section what you want, and basically I will make a video for you all what is your need on that basis. So let's start with our discussion with chapter number 2, acids, bases and salt. So first of all, we are going to discuss that you have seen in your NCERT textbook that some one table is given, table number 2.3. In that, some natural sources and which acid is present in that is given. So these questions can come from here, from this table. 1 or 2 marks question can come in your exam. It is very important. Like for example, in vinegar, the vinegar which we use in the Chinese food, or even we use in some of the pickles, in that which acid is present? In vinegar, acetic acid is present. Acetic acid. Even the chemical name of vinegar is acetic acid. Now next, orange. Orange is a citric food. So in orange which acid is present? Citric acid is present. Tamarind, from the name you can understand, tamarind, tartaric acid. T for tamarind, T for tartaric acid. Remember like that. So in tamarind, tartaric acid is present. In tomato, oxalic acid is present. Tomato, oxalic acid. Okay, now we have curd. Curd we make from milk, and in curd which acid is present? In curd, lactic acid is present. Lactic acid is present in curd. Next, lemon is again a citric food like orange. So in both lemon and orange, citric acid is present. Ant sting. You have seen many times honeybee will sting us, or big ant, which are in black in color, they used to sting us, and it's very painful. When they sting us, they inject methanoic acid in our skin. Methanoic acid. Even the nettle sting. Nettle is a leaf which you can see near the roadsides or in jungles or in forest. If that leaf will also come in contact with you, it will also inject methanoic acid in your skin, and that is also very painful. So these are some of the natural sources along with the acids present in them. So let's revise it once again. So in vinegar, acetic acid is present. Orange and lemon, citric acid. Tamarind, tartaric acid. Tomato, oxalic acid. In curd, lactic acid. Ant sting and nettle sting, methanoic acid. I hope it's easy for you to learn. Please learn this table because from it questions can come. Now let us look at the pH scale. You know that pH ranges from 0 to 14. If you look at the pH scale, it ranges from 0 to 14. When you will move towards 0, acidic character will increase over there. Acidic character will increase. 7 is a neutral point. 7 is a neutral point where the pH level, if the pH of the solution or any other substance is equal to 7, we can say that the substance is neutral in nature. But as we move from 7 to 14, the basic character increases. Basic character increases, that is OH minus ion increases, and in acid H plus ion increases. So one question was asked in the model paper of Karnataka State Board that what will happen if the pH of the solution increases. So you have to mark in that answer, as the pH of the solution increases, the basic character, that is OH minus ions, increases. Over there, as you can see, the pH of gastric juice, it is about 1.2, means the gastric juice which is secreted in our stomach is acidic in nature. The lemon juice, in lemon, acid is present, citric acid, so obviously it will be acidic in nature, and it's 2.2. The pH value is 2.2. Next, pure water or blood, they are neutral in nature and their pH is about 7.4. Their pH is about 7.4. Milk of magnesia is a base and its pH is about 10. Next, sodium hydroxide solution, NaOH solution, its pH is 14. So it is very basic in nature, as in sodium hydroxide more number of OH ions are present. Now next we are going to discuss some of the important reactions of acid and bases. So as you all know that whenever a acid or base will react with any metal, Okay, what I am saying, that whenever any acid or base will react with any metal, always salt will be formed. Along with that, hydrogen gas will be liberated. So what we know, that whenever a acid will react with metal or a base will react with a metal, always salt will be formed, and along with that hydrogen gas will be liberated. Hydrogen gas will be evolved. Let us take an example of acid. Suppose HCl. HCl is reacting with magnesium. So a salt called magnesium chloride will be formed, MgCl2 plus hydrogen gas will be evolved in that reaction. Magnesium is a metal and HCl is an acid. So whenever an acid will react with magnesium, magnesium chloride along with hydrogen gas will be formed in the reaction. Next we can take an example for a base. So let us take an example of NaOH. NaOH is a very strong base. NaOH plus, let us take a metal called NaOH is a base. Let us take a metal called chlorine. Sorry, chlorine is a non-metal. NaOH plus, you can take zinc also, plus zinc plus Zn. Okay, NaOH plus Zn, zinc. So which salt will be formed over there? Na2ZnO2. Na2ZnO2 plus H2 gas will be evolved. Na2ZnO2. What is the name of this compound? It is called sodium zincate and it is a salt. So whenever a base will react with a metal, we will get a salt and hydrogen gas will be liberated. I have provided this reaction over there also. Twice NaOH plus Zn gives Na2ZnO2 plus H2, and this reaction is important from your exam point of view. So practice this reaction. Sodium hydroxide, when it react with zinc, sodium zincate will be formed, Na2ZnO2. Along with that hydrogen gas will be liberated, because in this reaction a base is reacting with a metal. Next one, this activity you have done in your junior classes also, and in 10th standard also you have done. Whenever carbon dioxide gas is passed through lime water, what happens? Lime water turns milky, correct? So whenever we will pass carbon dioxide gas through lime water, it turns milky. So what is the formula for lime water? It is CaOH whole 2, calcium hydroxide, CaOH whole 2. In that, when you will pass carbon dioxide gas, CO2 gas, your precipitate will form, white precipitate will form, which is not soluble in water. And what is the name of that precipitate? Calcium carbonate. Calcium carbonate. It is not soluble in water and it is white in color. Along with that, water will also be formed. So whenever carbon dioxide gas is passed through lime water turns milky, and a white color precipitate is formed of calcium carbonate. Along with that, water is formed. Along with that, water is also produced. But if we pass excess of carbon dioxide through this solution, then what will happen? The milkiness will disappear. When you will pass excess of carbon dioxide, means you have to take these products, CaCO3 plus H2O. In that you have to pass more carbon dioxide. What will happen? Calcium hydrogen carbonate will be formed, which is soluble in water, and this substance is soluble in water. Calcium hydrogen carbonate will be soluble in water, and the milkiness will also be disappeared. Next, neutralization reaction. It is very important reaction. So what is neutralization reaction? Neutralization reaction is that reaction in which an acid will react with a base to form what? To form salt and water. To form salt plus water. So neutralization is a reaction in which acid reacts with a base to give us salt and water. Right? So let us take an example of that. Let us take NaOH. NaOH is a base, and we can take an acid called hydrochloric acid, HCl. So Na will combine with Cl to form NaCl, and along with that water will also be formed. So NaCl is a salt and water is formed. So neutralization reaction is that reaction in which an acid will react with a base and it gives us salt and water. So this question can come for 1 or 2 marks. In that you can get what is neutralization reaction. Give one example. So you can write the definition of neutralization reaction. The reaction in which an acid will react with a base to give us salt and water is called neutralization reaction. And in example you can give NaOH plus HCl gives NaCl plus water, H2. Now let us come to the next part of this chapter, that is some important salts or some common salt. From this section also questions are asked, that what is the chemical formula of bleaching powder, write its two uses. What is the chemical formula of washing soda, write its two uses. So this part is very important from your exam point of view. So first of all, we will discuss about sodium hydroxide. What is the formula of sodium hydroxide? It is NaOH. Formula of sodium hydroxide is NaOH, right? And it is a base, correct? Sodium hydroxide is a base. And how the sodium hydroxide is formed, let us read that. So when electricity is passed through an aqueous solution of sodium chloride, okay, this reaction you can consider. When we will pass electricity through aqueous solution of sodium chloride, aqueous means in that some amount of water is also produced. So aqueous solution of sodium chloride is also called brine. NaCl plus H2O, it is called brine. It will decompose to give sodium hydroxide, NaOH, chlorine and hydrogen gas. Decompose means it will break down to give you sodium hydroxide, chlorine gas and hydrogen gas. Okay, so how sodium hydroxide is formed? When electricity is passed through aqueous solution of sodium chloride, it decomposes to give us sodium hydroxide, chlorine and hydrogen gas. And this process is called chlor-alkali process. This process is called chlor-alkali process. And why this process is called chlor-alkali process? Because one of the product is chlorine and one of the product is alkali. NaOH is the alkali, that is the base, and chlorine you have seen. So now one question can come in this section also. Name two gases which are formed, which are produced in chlor-alkali process. So the two gases which are produced in chlor-alkali process are chlorine gas and hydrogen gas. So what is the use of this chlorine gas? Chlorine gas is used in killing the germs present in the drinking water or in swimming pools also. Then chlorine is also used to make PVC, disinfectants, CFC, chlorofluorocarbon and many of the pesticides. So one or two uses you can remember for chlorine. Next, what is the use of this hydrogen? Hydrogen is used as a fuel in rockets, right? It is also used for the manufacture of ammonia, NH3, and in many of the fertilizers. So one or two uses you can remember for both chlorine and hydrogen. Now this chlorine gas is formed at the anode. You can see this is the picture of chlor-alkali process in which two electrodes are taken, anode and cathode. So this hydrogen gas is formed, chlorine gas is formed at the anode and hydrogen gas is formed at the cathode, and sodium hydroxide solution is formed near the cathode. Near the cathode you can see this sodium hydroxide solution you can take out through this outlet. This is your main product, and through this inlet we have to provide brine solution and then we have to pass electricity. When you will pass electricity, this brine solution will decompose to give you NaOH, chlorine and hydrogen. Chlorine will be formed at the anode and hydrogen gas will be formed at the cathode, and this sodium hydroxide will also be formed near cathode and we can get it through this outlet. Now, what is the use of this NaOH solution? There are many uses of NaOH solution also. It is used for degreasing metals, even for manufacturing soaps and detergents also sodium hydroxide is used. In paper making, in artificial fibers. So these are the uses of sodium hydroxide. So I recommend you to learn the uses of chlorine, hydrogen and sodium hydroxide, because this question can be asked in the exam. And also remember that chlorine is formed at the anode, and hydrogen gas is formed at the cathode. So this was all about your sodium hydroxide. Next let's come to the next salt, that is called bleaching powder. And bleaching powder is also very important. Bleaching powder is also very important. So what is bleaching powder? Bleaching powder is, what is the formula of bleaching powder? It is CaOCl2, calcium oxychloride, and its chemical name is calcium oxychloride. And how this bleaching powder is formed? It is formed by the action of chlorine on dry slaked lime. You have to pass chlorine gas through slaked lime, that is calcium hydroxide, CaOH2. CaOH2 will react with chlorine to give you calcium oxychloride, CaOCl2 plus water. Okay, so this is a reaction for bleaching powder, means how bleaching powder is formed. So if the question will be asked how bleaching powder is produced, you will write that bleaching powder is produced by the reaction of chlorine with dry slaked lime. And what is this dry slaked lime? It is calcium hydroxide, CaOH2. And remember the chemical formula of bleaching powder, it is CaOCl2. Correct? Now let's come to the uses of bleaching powder, which is very important. One of the most important use, you all know that bleaching powder is used to make drinking water free from germs. Means it is used for killing the germs present in drinking water. Next, it is used for bleaching. As the name indicates, it is used for bleaching cotton and linen in the textile industry. These are the cloth materials, cotton and linen. Bleaching powder is used to bleach these cotton and linen in the textile industries, for bleaching wood pulp in the paper factories, and for bleaching wash clothes in the laundry. So most important use of bleaching powder is that it is used as a bleaching agent in textile industry, in paper industry, and even in the laundries also. Then it is used as an oxidizing agent in many chemical industries. As you can see that in the formula of bleaching powder, oxygen is present, so it can provide oxygen. It is acting as an oxidizing agent in many chemical industries. Now let us discuss about the baking soda. So what is the formula of baking soda? The chemical formula of baking soda is NaHCO3, sodium hydrogen carbonate, and the chemical name is sodium hydrogen carbonate. So the chemical name of baking soda is sodium hydrogen carbonate and the formula is NaHCO3. It is produced using sodium chloride as one of the raw material. And how we can get baking soda? By the reaction of sodium chloride with water, carbon dioxide and ammonia. These four reactants are needed to make baking soda. So when sodium chloride will react with water, carbon dioxide and ammonia, we get ammonium chloride. Along with that we get baking soda also, NaHCO3. Ammonium chloride, what is the formula of ammonium chloride? It is NH4Cl, and along with that we get sodium hydrogen carbonate, NaHCO3. The following reaction takes place when it is heated during cooking. Now we have to heat sodium hydrogen carbonate. You know that baking soda is used in we use in many things. Whenever we used to bake cookies or cakes or biscuits, we add a pinch of baking soda in that. In many of the food items also we use baking soda, right? So what happens when baking soda is heated? When we add baking soda in any of the food and we cook them, then what will happen? Baking soda will decompose to give you sodium carbonate, water and carbon dioxide gas. The carbon dioxide gas which is released during this process make the cakes and breads soft and fluffy. The carbon dioxide gas which is released during the cooking process makes the bread and cakes fluffy and soft. So remember that the chemical name of baking soda is sodium hydrogen carbonate and the formula is NaHCO3. And how it is formed? It is formed by the reaction of sodium chloride with water, carbon dioxide and ammonia. Next, whenever baking soda is heated, carbon dioxide gas is produced which makes the cakes, breads soft and fluffy. Now let us read about the uses of baking soda, which is also very important from your exam point of view. So first use of baking soda is for making baking powder. So this is baking soda, right? One more component which we use for making cake is baking powder. You can get that in the grocery shops. Baking soda is different thing and baking powder is different thing. Baking powder is a mixture of baking soda and tartaric acid. So what is baking powder which we use to make cake? It is a mixture of baking soda and tartaric acid. Tartaric acid is a mild type acid, very weak acid. So these both, when baking soda is mixed with tartaric acid, we get baking powder. And baking powder is heated or mixed in water, the following reaction takes place. And what happens when baking powder is heated or mixed with water? NaHCO3 plus H plus gives CO2 H2O plus sodium salt of acid. You can see that over there also carbon dioxide gas is produced which makes the cakes and bread very soft and spongy. So one question can come, why we add baking soda in cakes and bread? So you can write that we add baking soda in cakes and bread because it makes the cakes and bread fluffy, which is because of the carbon dioxide gas released in the cooking process. Next point. So first use, you can write that baking soda is used for making baking powder, which is a mixture of baking soda and tartaric acid. Baking soda is used in cakes and breads which make them soft and spongy. Next one, sodium hydrogen carbonate is also an ingredient in antacids. So what are antacids? Sometimes what happens when we eat spicy and oily food, we suffer from acidity. So to get relief from that acidity, we use anti-acid tablets. So sodium hydrogen carbonate can give you relief from acidity. So it So it acts like a antacid. Being alkaline, it neutralizes excess acid in the stomach and provides relief. So it is basic in nature. Sodium hydrogen carbonate, that is baking soda, is basic in nature. So whenever you can suffer from acidity, you can have a pinch of that. You can easily get relief from that. Next one, it is used in soda acid fire extinguisher. It is also very important fine point. It is also used in soda acid fire extinguisher. So you can remember 3 or 4 uses of baking soda from here. That first point you can write, baking soda is used for making baking powder. Second use you can write, baking soda is used in many of the food items like in cakes and breads, which make them soft and spongy. Third use you can remember that sodium baking soda is used as an antacid. And the fourth use you can remember that it is used in soda acid fire extinguisher. Now let us read about the next type of salt called washing soda. So once again we can recall the chemical formula of baking soda. It is NaHCO3, sodium hydrogen carbonate. Now the next one which we have to read is washing soda. Washing soda, what is the chemical formula of washing soda? It is Na2CO3 dot 10H2O. Means 10 molecules of water of crystallizations are attached with the with 1 unit of washing soda, that is Na2CO3. It is sodium carbonate decahydrate. What is the chemical name of washing soda? It is sodium carbonate decahydrate, and the formula is Na2CO3 dot 10H2O. Don't miss 10H2O when you write the formula of washing soda. Okay. And how this washing soda is obtained? It is obtained by heating baking soda, and recrystallization of sodium carbonate gives washing soda. It is also a baking salt. So when you heat baking soda, that is NaHCO3, you get sodium carbonate. Okay. And in sodium carbonate, when you add water molecules, 10 molecules of water, you will get washing soda. So what's washing soda is formed by recrystallization of sodium carbonate. When we add 10 molecules of water to sodium carbonate, we get washing soda. And there are many uses of washing soda, right? So let us read about the uses of washing soda. Washing soda is used in glass, soap and paper industries. So the sodium carbonate, that is Na2CO3.10H2O, also known as washing soda, is used in glass, paper and soap industries. It is used in the manufacture of sodium compound called borax. So washing soda is also used to make borax. Next one, sodium carbonate can be used as cleaning agent for domestic purposes. In our house you can see that for cleaning anything, for washing the clothes, for cleaning the floors, tiles, etc., we use washing soda. It is used as a cleaning agent in our houses. Next one, it is used for removing permanent hardness of water. It is very important point. Washing soda is used to remove permanent hardness of water. So these are the 4 points which you can remember for the uses of washing soda. It is used in glass, soap and paper industry. It is used for manufacturing borax. Next one, it is used in our houses as a cleaning agent, and it is used to remove permanent hardness of water. Now let us read about the last type of salt which is given in your textbook, that is plaster of Paris. Okay, so what is the formula of plaster of Paris? It is CaSO4 dot half H2O. CaSO4 dot half H2O. Calcium sulfate hemihydrate, and its chemical name is calcium sulfate hemihydrate. Hemihydrate means half H2O. Half water molecules is attached with the one formula unit of plaster of Paris, CaSO4. So how we get this plaster of Paris? When we heat gypsum. What is gypsum? CaSO4 dot twice H2O. This is called gypsum. This is the formula of gypsum. Calcium sulfate decahydrate. This is a formula of gypsum. So when you heat gypsum at 373 Kelvin, at this temperature only we have to heat gypsum. So what happens? This gypsum will lose water molecule and become calcium sulfate hemihydrate. Half of the one and a half molecule of water is loosed, and we get calcium sulfate hemihydrate. So let us write the reaction for the formation of plaster of Paris. So this is our gypsum, CaSO4 dot twice H2O. When you heat it at a temperature of 373 Kelvin, don't forget to write the temperature, it is 373 Kelvin, we get CaSO4 dot half H2O. It is called plaster of Paris. Along with that, 1.5 molecule of water is lost. So this is your plaster of Paris, and you get 1.5 molecule of water molecule. So when gypsum is heated at 373 Kelvin, it loses water molecule to give you plaster of Paris, that is calcium sulfate hemihydrate. Now again, if you add water molecule to plaster of Paris, what we will get back? We will get back gypsum again. See, plaster of Paris is a white powder. On mixing with water, it changes to gypsum, once again giving a hard solid mass. So this is your plaster of Paris, CaSO4 half H2O. If you add 1.5 water molecule again to it, you will get gypsum, that is CaSO4 dot twice H2O. Now let us read about the uses of plaster of Paris. Nowadays you can see that there are so many uses of plaster of Paris. People are making different types of decorative items from plaster of Paris. Okay, now the first and the most important use of plaster of Paris is that it is used by the doctor for supporting the fractured bones in the right position. If you have got any injury in your hand or legs, you have seen that the doctors will use this to make your to correct the position of the bones and by doing that plastering process. Next one, it is used for making toys and many of the decorative items in our house. Material for decoration and for making surfaces smooth means it is used for making many of the decorative items, statues, etc., and also used to make the surface smooth. So these are the different uses of plaster of Paris. So we have read about the different types of salt. So let us recall that what we have read. So first of all, we have read about some of the naturally occurring acids which are present in different types of substances. In vinegar, acetic acid was present. In orange and lemon, citric acid. In tamarind, tartaric acid. In tomato, oxalic acid. In curd, lactic acid. In ant sting and nettle sting will give you methanoic acid. Next, we have read about the important reactions of acid and bases. So whenever an acid and base will react with a metal, you will get salt plus hydrogen gas. Next, we have read that whenever carbon dioxide gas is passed through lime water, it turns milky. But passing excess of carbon dioxide gas through lime water, the milkiness disappear. Next, we have read about neutralization reaction also. So what is neutralization reaction? Whenever a acid or base will react with each other, we get salt and water. Next, we have read about the common types of salt. First of all, we have read about sodium hydroxide. It is formed by passing electricity through an solution through an aqueous solution of sodium chloride, and it decomposes to give you sodium hydroxide, chlorine gas and hydrogen gas. Chlorine gas is formed at the anode, hydrogen gas is formed at the cathode, and sodium hydroxide is formed near the cathode, and this process is called chloralkali process. Next, we have read about bleaching powder. The chemical formula of bleaching powder is CaOCl2 and its chemical name is calcium oxychloride, and it is formed by the reaction of slaked lime with chlorine. Uses of bleaching powder: it is used as a bleaching agent in textile industry, paper industry, and even in laundry. Used as an oxidizing agent in many chemical industries, and used for killing the germs in the drinking water. Next, we have read about baking soda. The chemical name of baking soda is sodium hydrogen carbonate, and the formula is NaHCO3, and it is used by the reaction of sodium chloride with water, carbon dioxide and ammonia. Right? Next, whenever baking soda is heated, carbon dioxide gas is liberated, which makes the breads and cakes fluffy. Now, if we talk about the uses of baking soda, there are many uses of baking soda. First of all, it is used for making baking powder, which is a mixture of baking soda and tartaric acid. And baking soda is used in many of the cakes, breads and pastries, which make them soft and spongy. Next, we have read that it is used as an anti-acid. Next, it is used it is used in soda acid fire extinguisher. Okay, the next type of salt which we are going to read is, which we have read, is washing soda, and the chemical name of washing soda is sodium carbonate decahydrate, and the formula is Na2CO3.10H2O. And how it is formed? When baking soda is heated, we get sodium carbonate, and if water and 10 molecules of water molecules are added to sodium carbonate, we get washing soda. Uses of washing soda: it is used in glass, soap and paper industries. It is used in the manufacture of an important sodium compound called borax. It is used as a cleaning agent in our houses, and it is used for removing permanent hardness in water. Next, we have read about plaster of Paris. How we get plaster of Paris? When gypsum is heated at 373 Kelvin, we get plaster of Paris. And at last, there are some uses of plaster of Paris are also there. It is used by the doctors for making the bones in the correct position, and it is used for making toys, and it is also used for decorative purposes and making the surfaces smooth, and even in many statues. So I hope you all have understood what I have told you. So thank you for watching, and if you have